Hello everyone, welcome to this set of series in MCQs of discrete mathematics. This video will cover the MCQs in the set theory. As we have already said, this is going to be just a limited edition of frequently occurring things which will touch upon the basics so that if you are strong with your basic, then you can handle whatever be the sort of question that arises in the MCQ in set theory. We'll get started. Question number 1, which says that if A is going to be a set that contains 3 elements 2, 4 and 6, then the number of subsets of A. Okay, you need to keep in mind the number of subsets of any given set is given by 2 to the power of n. Okay, so what is going to be n? 1, 2, 3 for us. So over here it is 2 to the power of 3, so that makes it to be equal to 8. So answer is going to be 2 power 3, which is going to be 8. So since the expression 8 is not here, you can just mark for 2 power 3, which will be your answer. Next, let A is going to be a set that contains 10 elements totally. Then the number of subsets of A containing exactly 3 elements. Okay, there are going to be very many subsets of A that can be generated. But what you are interested in is going to be exactly 3 elements. So out of 10 elements which is available in A, you are going to choose only 3 elements. So that is nothing but your 10C3. So what is going to be your 10C3? Exactly 3 elements means 10C3. So it is 10 into 9 into 8 by 1 into 2 into 3. So 3 goes over here 3 times. 2 goes over here 4 times. 4 3s are 12. 12 into 10 makes it as 120. Use your calculator wisely. You can just key in 10C3 in your calculator and also get your answer without any error. So the answer for your quantity, out of 10 elements, 3 elements can be picked exactly in 120 ways. Next, the relation R is defined on the set of integers is given by A minus B is such that A minus B is divisible by 3. It is defined on the set of integers. Okay, so you will have to show that whether it is going to be reflexive, symmetric, transitive or equivalence relation. What do we mean by reflexive? Whenever we have A comma A to belong to the relation for all your A belonging to the set, then you call the relation to be reflexive. What do we mean by symmetric? Symmetric is one whenever A comma B belongs to the relation, your B comma A also belongs to the relation. So in which case you call it to be symmetric. What do you mean by transitive? Your transitive meaning A comma B belongs to the relation and you also have B comma C belonging to the relation, then you will have this both of them together to imply A comma C belongs to the relation. If a relation is going to be reflexive, symmetric and transitive, then it will be referred by the name equivalence relation. So we will have to check what is going to be true over here. So the first one, reflexive, is A minus A. A minus A is going to be 0 and 0 is divisible by 3. So this relation is going to be reflexive in nature. If A minus B is going to be divisible by 3, I can write this A minus B as your 3 times of K. So what will be B minus A? B minus A will be minus 3 times of K, which will also be divisible by 3. Therefore, it is going to be symmetric. So if A minus B is going to be divisible by 3, let me write it as 3K. B minus C is divisible by your 3. So let me write it as 3M. So what will be A minus C? A minus C is just addition of the two datas. Minus B plus B cancels off. So it is 3K plus 3M. Take your 3 common outside. K plus M. Is 3 times of K plus M divisible by 3? Yes, 3 times of K plus M is also divisible by 3. Therefore, you can say it is going to be transitive. So it is reflexive. It is symmetric. It is transitive. All the three relationships hold true. Therefore, you can conclude this divisibility of A minus B by 3 is going to be an equivalence relation. Now, if f is a function from A to B and the number of elements of A is going to be 2 and number of elements of B is going to be 4, then the number of functions that can be defined from A to B, this number of function has a general formula n of B to the power of n of A. So n of B is going to be 4 and n of A is going to be 2. So it is 4 into 4, 4 fours are 16. So the answer is over here 16. So we are done with the first set. Let us move to the second set of data. If the relation R is going to be reflexive, symmetric and transitive, then the relation R is called as equivalence relation. Just now we saw it. What is meant by a poset? Poset and a partial order relation is both one and the same. And what is going to be a poset or a partial order relation? If it is going to be reflexive, it is going to be anti-symmetric, and if it is going to be transitive, then these three together will contribute a partial ordered relation which we refer as poset. Okay, so what is meant by anti-symmetry? A comma B belong to the relation and B comma A belonging to the relation will imply A equal to B. It is very much different from that of the symmetric relation which we saw. Symmetric relation means A comma B belongs to the relation, means that has to imply B comma A is also there in the relation. But for anti-symmetry, both of them have to hold true. A comma B belongs, B comma A also belongs. Then what does it imply? A equal to B. This is called as anti-symmetry. So if it is reflexive, anti-symmetric and transitive, then you call it as partial order relation, or you call the set which is going to satisfy this by poset. What is identity relation? The relation of the format A comma A belonging to the quantity will be called as identity relation. Next, coming to the second one, the dual of x is equal to B bar intersection A union A intersection B. How to get the dual of any statement? Wherever you have union, you replace it with intersection. Wherever you have intersection, you replace it with union. Wherever you have null set, you replace it with universal set, and universal set has to be replaced with null set. So this is going to be the four transformation which we are going to do to obtain what is going to be the dual of the given statement. So over here, this is going to be B bar. Don't change B bar to B. That is not the way in which a dual is obtained. A complement is never changed in your dual. Keep it in mind. So it is B bar. This intersection will now change as union A, and this union will now replace with intersection and A. This intersection will now become union and B. Let us search for our answer. Answer is available in option number C. So this is going to be our answer. Next, F is from A to B and G is from B to A. Then G composition F is going to be. So what happens? You have a composition of function G composition F, which means G of your function f of x. So we begin with f and move towards g. That is, we begin with f. Where is the beginning? A, and it goes to b. F takes elements of A to B, and where does G take? G take elements of B to A. So this B, which is going to be the ending point, will become the starting point of G, and this G now will take elements of B to A. So your G composition F are elements from A to A. But A to A doesn't imply that it has only identity elements of A. There can be very many elements which can form a combination. So IB is not the answer. Does not exist is not the answer, because it does exist. So the answer will be many to one. The next one, A is going to be the set 3, 4, 5. R is defined as the relation on A such that the ordered pair x comma y, such that x plus y is greater than 10. You want the combination of the ordered pair which will give you on addition the value greater than 10. So 3, let me take a combination with 4. 3 comma 4 meaning 3 plus 4. Is it greater than 10? No. So this will not be there in the relation. 3 with 5, 3 plus 5. So this is 8. So this will not be there in the relation. Next, let me take a combination with 4 and 3. 4 comma 3 is again 4 plus 3. No, it is not true. 4 comma 5, it will be 4 plus 5, which is again 9, which is not greater than 10. So this will not be there. 5 comma 3 is 8. So this will not be there. 5 comma 4, this will also not be there. So we will see that, we see that these are not going to satisfy. 3 4 not there, 4 5 is 9, 5 3 is 9, 8, so this is not there. 4 4 is going to be 8, 4 5 is going to be 9, 5 5 is going to be equal to 10, so this will not be there because the other numbers are not greater than 10. Now coming to this number 5 comma 5, 5 plus 5 is going to be equal to 10, but the relationship states that x plus y must be greater than 10. Okay, so is it greater than 10? No. So whatever be the possible combination you take, whether it is 3 comma 3, 4 comma 4, 5 comma 5, or 3 4, 3 5, 4 3, 4 5, whatever be the possible combination you take, you don't get your answer to exceed 10. So how many elements does the relationship have? It has no elements, so your answer is R is equal to 5. What do you mean by 5? 5 is going to be an empty set. Next, we will move on to the next set of relations over here. If f is a function from a to b, g is from b to c are bijective. Okay, so a is f is going to be bijective. F is going to be bijective and your G is also going to be bijective. F is bijective and your G is going to be bijective. Then your G composition F, which is the combination of both, is also bijective. So this is going to be the property. If F is going to be 1 1 and on 2, you call it to be bijective. G is 1 1 and on 2, it is bijective. Then G composition F will also be 1 1 and on 2. So this will imply that G composition F is also a bijection. So the answer is going to be A over here. If A is going to contain 6 elements, the cardinality of power set of A. What do you mean by a power set? Power set is the number of collection of possible, not number, collection of possible subsets of your given set. So say suppose your A is going to contain 1, 2 and 3. Then how many ways in which we can have this element is going to be, your power set of A can contain no element at a time. It contain one element at a time. It can contain 2 elements at a time. It can contain all the 3 elements 1, 2, 3 at a time. So a collection of this format, a collection of all possible subsets of A, will be denoted as power set of A. And how to get this? This is nothing but it is got by 2 to the power of n. So what is going to be our n over here? N has been given as 6. So it is going to be 2 to the power of 6. And what is going to be 2 power 6? It's going to be 64. So the answer for this will be equal to 64. Next, if MR represents the matrix relation on a set A such that your MR matrix relation is going to be the same as MRT, T meaning transpose, MR and MR transpose. When will your A be equal to A transpose? This will hold only when the relation or the matrix is going to be symmetric. What do you mean by symmetric? Along the diagonal you take both above and below the diagonal if you are going to have the same element. Like this is going to be 2, 1, minus 1. if you have 3 here, you will have to have 3 here. If you are going to have 1 here, you will have to have 1 here. If you are going to have 2 here, then you will be having 2 here. So what happens, this is going to be my diagonal. Above and below the diagonal, the elements are the same. So when you take transpose to this, it will again be the same. What do you mean by transpose? Interchange your rows to columns and columns to rows. So when will this happen? Only for a symmetric matrix. Okay. Next one, which of the following forms a partition of the set A? What do we mean by partition? Partition meaning we are going to break down the set into parts and or subsets. And what are going to be the rules in it? The rule is such that when you take the collection of all the partitions, you will have to get back your original set, and there must be no overlapping of elements. That is, your pi intersection pj must be the intersection, that is number of common elements must be equal to 5. That is, there must be no elements which is common to the two partition. You cannot have an element which all belongs to partition 1 as well as in partition 2. So these are going to be the two conditions we will be following. In which case, what happens over here, 1 comma 2, 1 comma 3. 1 is repetitive over here as well as here. So this is not a partition. Okay. 1, 2, 3. 3 is repeated here, 3 is repeated here. So this is not a partition. 1 comma 2 and 2 comma 3. 2 is being repeated here. So this is not a partition. And 1 as one singleton set and 2 comma 3 as other set. When you take the union, you get all the 3 elements back and there is no overlapping. So the right answer is going to be C, set of collection of 1 and 2 comma 3 as singleton, as a separate set. Moving on to the next one. If we have A and B to be non-empty sets, then A intersection B union A. So A intersection B union A can also be written as A union B. A intersection A union B by absorption law. Absorption law states that is going to be equal to your A. In A elements that are going to be common to A, and this is going to be your A union B. A union B will just be the element of A alone. Okay, so the answer is going to be B, which is going to be your A. Coming to the next one, you have a collection of R and a collection of S defined on the set A. Then you want R composition S. R composition S is R of S of the elements X. So this is how we define the composition of functions. Start from S and then move towards R. In which case, what is happening over here? You take the first element over here, 2 is mapped to 1. And where does 1 go in your R? 1 is mapped with 1. So what will happen ultimately? This 2 will be mapped with 1. So 2 comma 1 will be your ordered pair. 2 is mapped with 1. Where is this 1 mapped to? 1 is also mapped with 3. So 2 comma 3 is also the other ordered pair. The next one, 3 is mapped with 3 in your S. And where is 3 mapped to? 3 is mapped to 2. So 3 comma 2 is one set. And 3 comma 4 is 3 is also mapped with 4. So 3 comma 4 is also your other set. Next, 3 is mapped with 4. And where does 4 go in your R? 4 is mapped to 2. So 3 comma 2. But 3 comma 2 is already present, so we ignore that. Okay, and now coming to the next element, 4 comma 1. 4 is mapped with 1. 1 is mapped with 1. So 4 comma 1 is one element. 1 is also mapped with 3. So 4 comma 3 is going to be the other element. So your composition R, composition S must contain the elements 2 1, 2 3, 3 2, 3 4, 4 1, 4 3. But unfortunately we are not able to find this combination in any of them. So this is the formal way of working your composition. But say suppose they have worked out in the other way round. What is going to be the other way round? They have started from your R and moved towards your S. In which case what will happen? One is mapped with 1 and one is not mapped anywhere, so it doesn't have a composition. Next element, when you take, one is mapped with 3 and 3 is mapped with 3 and 3 is mapped with 4. 3 is mapped with 3, 3 is mapped with 4. So 1 comma 3, 1 comma 4 is a combination of answer we get for composition of function. Next moving, 3 is mapped with 2, 2 is mapped with 1. So 3 comma 1 is one combination. Next 3 is mapped with 4. What is 4 mapped with 1? So 3 comma 1 is one more combination, but 3 comma 1 we already have. Next 4 is mapped with 2, and how about 2? 2 is mapped with 1. So 4 comma 1 is going to be one combination. And if you're going to check 1 3 1 4 3 1 4 1, yes, it is present over here. So instead of taking the usual notation of R of S of X, they have taken it as S of R of X. So they have begun with R and moved towards S, in which case your answer will be this. But the proper definition of your composition will be in this format. Composition always starts from the inner part and moves to your outer part. Next, coming to the question on F is from A to B, G is from B to C, is going to be bijective in nature. That is, it is both on 1 and on 2. G composition F. G composition F will begin with A, end with B, and it is given as input to G, where G takes it from B to C, so the function is from A to C. What will be the inverse of it? We know the property that G composition F, the whole inverse will be equal to F inverse composition G inverse. This is a property, you can just memorize it, and so your answer will be F inverse composition G inverse. So the answer will be equal to your A. Next, coming to your fourth question, F of X is 2x plus 3 and G of X is 3x plus 2, be a function defined on real numbers. Then F composition G. What will be F composition G? So this is going to be F of G of X, which means G of X is provided as input to your F. So it is F of, what is G of X? 3x plus 2. So wherever you have x over here, this x has to be replaced with 3x plus 2. So this will now give me 2 times of x is replaced as 3x plus 2, and you have a plus 3 over here. So your answer will be 2 3s are 6x plus 2 into 2 makes it as 4, plus there is a 3 outside, so it is 6x plus 4 5 6 7. So the answer is over here 6x plus 7. We move on to the next set of questions. A minus B is the same as B minus A if and only if the set A equal to B. Only if A and B are the same, then you can have A minus B to be the same as your B minus A. The next one, you have a relation R defined 6 to 8 to 10 to be a relation from B to A. Then R inverse, how to find R inverse? It's just A comma B belongs to the relation, then your R inverse will contain elements of the form B comma A. You will have to just flip the elements. So what happens over here? 6 comma 2 will be flipped as 2 comma 6. 8 comma 2 will be flipped as 2 comma 8. 10 comma 2 will be flipped as 2 comma 10. So these are the elements of your R inverse. Check where are they? 2 6, 2 8 and 2 10 over here in D. So this forms my answer for my R inverse. Next, Warshall's algorithm is applied to construct. We all know very well that Warshall is going to be an important algorithm which effectively helps us in constructing a transitive closure of any given relation. So the answer is transitive closure. Next one, f is a function from R to R and is defined by f of x is equal to 3x plus 7. So you have f of x as 3x plus 7, you need f inverse. F inverse is going to be equal to what? 3x minus 7 is equal to f of x. So your f of x is going to get mapped to the variables y by the function f. So your f of x is equal to y. Let me take this as y. In which case, what is my x equal to? What is going to be my inverse image? Y is given, what is x? So my x will be equal to y minus 7 comes this side, so this becomes plus 7. So 3x divided by 3, you go over here. So what is going to be the inverse image? It will be y plus 7 by 3. Y plus 7 by 3 is available over here. So this is going to be the inverse image. Moving on to the next set. The power set of A and singleton B over here is, what do you mean by power set? The collection of all possible subsets of this. So you have two elements over here, A and B. What is going to be the power set of this? The power set must begin with a null set, then elements taken one at a time. So a singleton A and a singleton of a singleton B, which is available. Elements taken one at a time and elements taken two at a time will be A comma a singleton B, which is already over there. So no at a time, one at a time, two at a time. So this is going to be the power set of the given set. We will see where does this option match for. Where does it match for? In our option number A. So this is going to be our option. Next, if P is going to be 1, singleton 2 and 4, Q is going to be 1, 2, 4, then can you say P is a subset? No, this is not a subset because 2 is a singleton set. Can you say Q is a subset of P? No, in that case also it is not true. Is P and Q the same? No, singleton 2 and 2 are not the same. So the option is perfectly P not equal to Q. So the next one, 3, 4, 5 and R is the relation x plus y is greater than 10. We just now saw this problem. So the answer for this will be equal to your value over here. 3, 4 combination will not work. 5, 4 combination is 9. 5, 3 is 8. 4, 3, 4, 5, 9, 10. No, nothing is going to be greater than 10. So obviously that going to be null set. No elements satisfy this relation over here. Again 2x plus 3 and gx is 3x plus 2, f composition g, f of g of x, the same problem which we did over here. So f of g of x, 3x plus 2, 2x plus 3, 3x plus 2, 2x plus 3. So the answer is going to be 6x plus 7, which is over here. Moving on to the last set of problems, we have A minus B intersection C. It's going to be an common set identity by the extension of De Morgan law. It is going to be A minus B, and when this minus sign gets extended, this intersection will turn out as union A minus C. So this is going to be your set identity. Where do we find this? With union here in A. So the answer is going to be here. If A is a non-empty set with n elements, then the number of possible relation on A. What is going to be a relation? A relation is going to be a subset of the Cartesian product. What is going to be the Cartesian product? Cartesian product is going to be A cross A. A is containing n elements, so A cross A will contain n square elements. So the number of possible relation is going to be 2 to the power of n square. Where is 2 power n square? Over here in C. So this is going to be our answer. Let R is the collection 1, 1, 2, 2, 3, 3 defined on the relation 1, 2, 3. Then the R is reflexive, symmetric, transitive, equivalence. What is this true? 1, 1, 2, 2, 3, 3 is going to be like A comma A. So this is going to be reflexive for sure. If A comma A belongs to the relation, obviously it's flip. What is its flip? A comma A is also belonging to the relation. So it is going to be symmetric. So you can call this to be a trivial symmetry relation. And how about transitive? If A comma A belongs to the relation and A comma A belongs to the relation, the combination of both of the quantity A comma A also belongs to the relation. So this can be a trivial transitive relation true. So it is both reflexive, symmetric as well as transitive, therefore it forms an equivalence relation. Next, F and G are going to be on 2, then the composition G composition F will also be on 2. Okay, so whatever be the nature of F and G, the same will be the nature of your composition. If F is 1 1 and G is 1 1, G composition F will also be 1 1. If F is on 2 and G is on 2, G composition F will also be on 2. If F is 1 1 and on 2, G is 1 1 and on 2, what do you mean by it? This is going to be bijective and this is also going to be bijective. Then the composition will also be bijective in nature. This is going to be a standard theorem which we have. Over here we have been given F and G are just on 2. The composition will also be on 2. So the answer will now tally with that of your C. So this video has given you a glimpse on what's the possible combination of questions that can arise out of the set theory portions we have learned for the basics of sets, the set relations, and then moving on to function and so on. So I suppose this has given you a wider view on the possible set of questions that can arise. Keep on learning. Happy learning. Thank you very much.